We are going to be combining lessons 10.3 and 10.4 together to talk about two big ideas with matrices, and they are called inverses and determinants. So the inverse of a matrix is, the way we write it is, it looks like a to the negative 1, but it's not. It's just the inverse. So if we have matrix A, the inverse looks like this. And the special thing about inverses is if you multiply A times its inverse or the inverse times A, you will always get the identity matrix. Okay, this is an I, not a 1, okay, in case you weren't sure about that. Okay, I is called the identity matrix. Now, not all matrices have an inverse. And the cool thing about inverses is they undo each other. Okay, so like multiplying by 5 and multiplying by 1/5. Those two things undo each other. They're actually inverses. So we have the same idea for matrices. So an identity matrix, we only have identity matrices when they're square. So if you have a 2 by 2 matrix, the identity matrix has 1 on the main diagonal and zeros everywhere else. So this is the 2 by 2 identity matrix. For a 3 by 3 identity matrix, it has 1 on the main diagonal and 0 everywhere else. So this is the 3 by 3 identity matrix. And if I can squeeze it in here, I can get you a 4 by 4. Okay, so it's going to have 1 on the main diagonals and zeros everywhere else. Now, the identity matrix, it's basically like 1. Okay, so just like 5 times 1 is 5. Any matrix times the identity matrix is just the matrix again. So that's why it's called the identities, because when you multiply by it, you just get the same thing that you started with. So we're going to take a look at a couple problems here. We want to show that A and B are inverses. So to do that, we have to multiply it both directions. So first we have to do A times B, and then we're also going to do B times A. So here's matrix A. It's 2 by 2. Matrix B is also 2 by 2, so we can multiply these. And our answer is going to be a 2 by 2 matrix. Let me switch colors so you can see it a little bit better. So remember, we multiply rows and columns. So we get -2 plus 3, which is 1. And then row 1, column 2. So that's -2 plus +2, which is 0. Row 2, column 1. It's going to give us +3 plus -3. And row 2, column 2 is going to give us +3 plus -2, which is 1. And now we need to show the other direction. We need to show that B times A is also the identity matrix. So we're going to multiply these. Again, they're both 2 by 2, so the answer is going to be a 2 by 2 matrix. Trying to do this not so sloppily. So we're going to take row 1 and column 1, and that gives us -2 plus 3, which is 1. Row 1, column 2 is going to give us +1 plus -1. Row 2, column 1 gives us -6 plus +6. And row 2, column 2 gives us 3 plus -2. So both of those turn out to be the identity matrix, so that means that A and B are inverses of each other. So now that we can see what inverses do, they undo each other. They multiply to the identity matrix. To find an inverse matrix, there's two different ways we can do it. We can write the matrix. So let's say we're doing matrix A down here, number 2. We can write matrix A with the identity matrix right next to it. So we kind of make this augmented matrix, and then we can put it in reduced row echelon form. And when we do that, it'll give us 1, 0, 0, 1, and then the 4 numbers over here will be the inverse. That's the inverse. But we can also use a calculator and just say, hey, Desmos, why don't you find the inverse? So we're actually not going to do this method. If you ever have to take a linear algebra course, you might have to do it by hand this way. But I'm going to show you how to find the inverse of this matrix. So if you want to find A inverse, we're going to go over to Desmos. And remember, we're not going to the graphing calculator. We're going to Math Tools, to the matrix calculator. And we're going to do a new matrix. It is 2 by 2, so that's great. And matrix A was 1. What else was it? -2, -1, 3. Okay, so we just hit enter and we have stored that. And then the keystroke's a little bit different here. You want to do A, and then down here, there's that A to the -1. That's right there that I picked. I didn't mean to press it multiple times. Okay, so that's what it should look like. And then over here on the right is your answer. So 3, 2, 1, 1. So A inverse over here is 3, 2, 1. We can do inverses of larger matrices. So if we have a 3 by 3, we'll go back to this matrix calculator. Let's put in a new matrix. This matrix B is going to be 3 by 3, and we'll put in the numbers. 1, -2, -1, 0, -1, 2, and 1, -2, 0. Okay, so that's matrix B. We'll hit enter. And then we want to take matrix B and do the inverse of it, and there it is. So we will show in the next video how what we can do with these inverse matrices. Right now we're just using Desmos to find them. In the next video we'll talk about get to some applications.